Greetings, and thank you for joining us for another SANS ICS Concept Overview. I'm Don C. Weber of Cutaway Security and a certified SANS instructor. In this concept overview, we are joined by Vivek Ponnada. Vivek is here to provide us an overview of the top 20 secure PLC coding practices. These practices are related to programming the process logic in a manner that is reliable and can protect the process against some common attack vectors. If you enjoy this video and the topics we cover in the SANS ICS concept overviews, be sure to like and subscribe to the channel. Leave a comment if you have a question about this topic or suggestions for future content. Thank you for joining us for another SANS ICS concepts video. Today we're joined by Vivek Ponnada. He's the Director of ICS Security at ICI Electrical Engineering in British Columbia, Canada. I got the pleasure of listening to Vivek speak at Houston SecCon 2021? Yeah, 2021 this year. And he talked about PLC security, the top 20. And I was really excited to go to his talk because I knew it was out there. I obviously don't do a lot of PLC programming myself, but I know how valuable this is for the industry going forward. So, I'm happy that Vivek, thank you for agreeing to come and talk to us about this important topic on the SANS ICS concepts videos. Why don't you go ahead and start by introducing yourself? Let everybody know how you started, and then go ahead and get into what you want to talk about.
Sure. Thanks, Tom. I appreciate you having me. I have a little bit of an introduction slide here. Like you mentioned, my name is Vivek Ponnada. I've been around the industrial control space for quite some time, been doing OT security for the past 8 years. I have an engineering background and a finance MBA from UT Austin, and I have a SANS cert for GICSP that you teach. I currently work as a Director of ICS Security at ICI. And we kind of focus on OT security solutions through engineering, including SCADA and PLC programming. And in my prior life, I was with GE for quite some time in field services, and I did sales and business development as well for them. And the way I got involved in this project is, Jake Brodsky did a presentation at S420 about securely programming PLCs, and Dale Peterson and Sarah Flukes were really interested in making that a much more functional kind of document that you can give to an engineer to help program better. And they started this project, and I got involved early on. So after years worth of work, we were finally able to get to an actual list that we can share and present to the rest of the.
Excellent. So I mean, you're coming at this from a different angle than I see a lot of people coming at this. You started actually on the control side, and then so how did you 8 years from moving from the control side and then moving into cybersecurity 8 years ago? That was quite a long time ago in kind of the the stage of security in this field being very young. So how did you get that transition? I'm pretty interested about that.
Sure. I mean, my transition was kind of natural because I worked for GE at the time, and GE not only sells gas turbines, but also gas turbine control systems. So my scope, a few years ago was to sell control system upgrades for oil and gas and power generation. So customers were, especially in the power gen sector, they were asking for, some kind of solution that works in the NERC world, something that assists them with, both the technical solution as well as the documentation side. So I was selling these control system upgrades and cybersecurity solutions for the power generation sector. And naturally, by extension, even the oil and gas customers, and I was in Texas at the time, covering the Gulf Coast, a lot of oil and gas customers were kind of evaluating their risk profile and kind of interested in what kind of solutions were there. And we were repurposing whatever worked in the NERC world into the oil and gas sector as well. And so my interest kind of peaked in that aspect because, like you mentioned, it was still very young, relatively developing industry. And I kind of liked the technical concepts, being an engineer myself and understanding the technical intricacies, but also how to manage that with the risk profile at the customer level. So I kind of went from being a field service engineer on a control system to selling control system upgrades and cybersecurity solutions to becoming a full-fledged cybersecurity professional.
That's awesome. So, one of the things that I say a lot and that I hear from whether it's integrators or whether it's vendors is getting the security requirements defined and put out to the people that are designing or updating solutions. So what are your thoughts on that, getting those requirements out as soon as possible? Have you seen this actually work?
Yeah, I mean, it works both ways, right? So one, there's a huge vendor community out there that's trying to educate because they want to sell a product. Then there is a whole bunch of government regulation focused on how to improve the infrastructure posture. And then the end user, the asset owner community trying to, do their day jobs, right? Trying to make a product or, provide a service without being attacked or without being, under some kind of stress. So in terms of requirements, I think all these are different, right? What an end user wants versus what a vendor would like to provide versus what the governments are different. But I think we're all triaging slowly but steadily. In my opinion, compared to even 4 or 5 years ago, now I see a lot of customers interested in asking for what's the right way to do this. What can we do to improve in our current legacy architecture, or should we be just replicating what we have in the future when we upgrade hardware, or is there something out there that we should consider? But of course, there's also a lot of selling by fear, right? So you want to avoid that by focusing on the core risk profile and kind of reducing the risk. So it's a challenge sometimes when you try to offer a solution, but someone else is trying to sell maybe a different product based on fear to a higher level, a business manager or a plant manager, and it's not the right solution for their plant, for example.
Excellent. Well, so I've digressed a little bit too much, but certainly that is a part of, I think, what PLC Security Top 20 items are about, is helping some of those requirements, or at least expectations of some of the vendors. So let me step back and let you go forward. Sure.
All right. So my contact info is down below. The question here is, everyone knows that PLCs, Purdue level 1, it could be DCS, it could be SCADA, it could be any controller at that Purdue level 1. We all know that, we have a lot of vulnerabilities out there. Plus, you hear this term insecure by design quite a bit. In fact, this project Basecamp is almost 10 years old, when, pretty much every PLC out there, every controller out there was kind of shown to be easily, hackable because, it was vulnerable by design. Plus, protocols historically have not had authentication or encryption. So we know that essentially this is a system full of holes. So why are we still talking about it, right? Mm-hmm. But let's consider the scenario where you have a threat, something happened to the PLC, and the process was either upset or tripped, and you're troubleshooting the usual suspects. You're going through your alarm list, your diagnostics, you even check the power supplies. But then, because there is a potential cyber threat, you ask this question, right? Is this a possible cyber attack, or is it just a device fault? Is the PLC just a problem, or maybe a power supply issue? Or is the PLC compromised? Can we restart safely? If somebody asks you this question, currently there is no easy way to answer this question. So even if it's a ransomware attack, like the Colonial Pipeline issue, where they shut down the process to be on the safe side, they knew that the attack was strictly on the IT side. But when you're restarting a SCADA system or a PLC, it's natural to ask, are we okay? Has this been compromised? But it's not really clear how to answer the question. So like I mentioned, when Jake did this presentation S420 about programming PLCs securely, he was trying to answer this question, is it possible to use maybe native functionality in the PLCs to build something around programming to answer these kind of questions? Not just that one question, but many others like that. And as we go through the list, you'll see that some of the questions will directly relate to what we saw at the Florida, Oldsmar, Florida situation, where someone was able to manipulate HMI values. If there were only things that you kind of planted in the PLC programming, thinking about these scenarios, you can answer the question without having to install, network sensors or anything higher level, any appliances or some kind of network intrusion detection. So there are things you could do in the PLC. But
so
like
when you're
mentioned,
talking about, so, and I'm sorry, Vivek, but when you're talking about secure PLC programming, there two thoughts come to my mind. There's the firmware that runs on the PLC, and then there's the actual program that is the logic for the process. My understanding is that this is covering the not the firmware, but the actual program that is monitoring and controlling the process. Is that assumption correct?
That's right. Yeah, so I think the difference is security of the PLC versus securely programming the PLC, right? So when, maybe I'll go to the next slide to kind of explain a little bit more. This is just where the PLC secure programming practices are listed. But if you look at this slide, this kind of explains what we're trying to do. So, you see this PLC, right? And, you got all the internal, whether it's memory or firmware of the PLC, that's tackled separately. Like if there's a vulnerability out there for a particular PLC firmware version, this programming practices list doesn't cover it because that's your standard, hardware vulnerability that you have to evaluate whether it's a good time to update or whether you have to defer. What this practice list is trying to do is to look at the code on the PLC itself that might impact your operations or any code. We're recommending a few alerts and changing programming a certain way. Again, that refers to actually using some kind of programming language in the PLC, not necessarily the firmware of the PLC or the IO packs or any of the hardware. That might come at a future level. Anything that is beyond just the PLC, something to do with maybe the firmware, something to do with the IO packs or power supplies or some kind of networking. We might, we collected some thoughts in it, and then maybe in the future, we might have a separate top 20 list for the PLC environment. But right now, we just focused on coding the PLC itself.
Thank you.
Sure. Yeah, like I mentioned, when we say PLC, we mean a controller. It could be a DCS, SCADA, or any kind of embedded system. So that's a generic term we use as a PLC because that's what is widely, more widely known. And here's a list. Without much further ado, we have these 20 lists. The way we came to it, we kind of compiled about 1,000 people's worth of thoughts. A lot of people contributed to it over years worth of time. Most of the people that were contributing to this list were at some point PLC programmers, but we also had OT professionals kind of giving guidance to the rest of the people as to, what's important, right? Like, why are we saying, this kind of log or monitoring is important, or why are we saying certain integrity checks are important? So we kind of combined the knowledge of, OT professionals who came with IT background and, OT professionals that came from, the PLC programming background. We'll talk a little bit more in detail about some of these practices. But just a basic structure, the PDF that you can download from that plc-security.com website will have this format. The first 2 pages are pretty straightforward, the top 20 list and a short description. Just one thing though, that these are all not ranked. So all 20 might be important for a certain application or a process, but for many others, maybe you want to choose, half a dozen or so because that's all is needed for that particular application.
So the prioritization is kind of left up to the actual programmers themselves, understanding what they have to do with the process.
Yeah, and not only that, we have this target group. So once you create a PLC code, and especially if you spend 5 years in a project, you'll know that the flowchart and the P&IDs and the cause and effect diagrams were done years ago, right? So once you created that logic and you did the SAT and the FAT, it's very hard to undo it, right? So depending on where you are in the process, let's say you're the end user and you look at this list, you're like, I can't really change 13 of these because these are all done, tested, and a lot of change management has to happen even if I want to touch something, right? However, maybe there are 5 or 6 of these practices that you can incorporate. Maybe you didn't trend the CPU runtime or memory usage. That's pretty easy for an end user to kind of look at it and follow. So that's what we did. Like the target group is probably what is the is the order that the 20 practices are listed, not necessarily a ranking. The other key objective here is, what are we trying to achieve? So when you look at each of the practices, you'll kind of understand what the practice is trying to achieve. So depending on the type of PLC you have, maybe a legacy PLC or maybe a more modern PLC with more security features built in, you might be able to do something differently with a lot less effort on a more modern PLC that supports certain features, but you still would be able to achieve what the target objective is, even on an older PLC, because you can have a guidance on each practice as to what this is trying to achieve. So in this example, integrity of IO values. In other practices, you'll see that it's for hardening the system. In other practices, it's about improving the resilience of the system once something happens. In other cases, it's about monitoring what's going on in the system. So once you know the concept, these are all best practices and kind of guidelines and not standards or procedures. So you can customize and adapt to your particular PLC and your particular application, because you can get a better feel for what this is trying to achieve. And then we also talked about, who this is intended for, because if you're an asset owner, you wouldn't have the resources or the time to go back and edit a whole bunch of logic. So you better put that in the RFQ for the next time when you're upgrading, so that the product supplier or the integrator can make those modifications for you to improve your system resilience. And of course, guidance and examples for each practice. And then the other benefits, some of these practices we kind of have been implementing for other reasons, maybe for maintenance purposes or for reliability purposes, but then having these security benefits tied to them, makes them much more attractive, right? That way, if you've been doing this already for some kind of reliability purposes, maybe you just needed to add an alarm to get the security benefit. So we kind of added some of the benefits that we saw for these practices besides security. And then finally, if you are a MITRE ATT&CK for ICS follower, or if you've been compliant to some kind of standard, following these practices, could help you identify some weaknesses and vulnerabilities or mitigate some of these attack vectors. And then, the security requirements can be fulfilled based on these mappings. MITRE CWE wants to come up with a PLC specific section as well, and we're collaborating with them.
Awesome.
Other frameworks are also available.
I really like that, because that is I have a lot of people ask that, what standards or frameworks are your tests and your checks for your security assessments? How, what do you recommend that we use and don't use? And people are going to select different things associated with what they already use in their companies, or what regulation requires for them to do. So I like this mapping, because now you can take this and easily map it within your organization if you are if that's one of the things that you're using to help improve your security program. So I'm glad you guys did that.
Sure, appreciate it. And this is an ongoing project. We'll talk about it in just a second. If there's someone out there with the capability to map it to another framework and would like to contribute, we more than welcome that and add that to the project. So we can discuss a few practices in detail. I took a relatively straightforward one using cryptographic or checksum integrity checks for the PLC code. So clearly, after PLC is shut down or something happened, you want to be able to confirm if the code that you have in the PLC is good, right? So what is that known good? So this kind of, whether the PLC code is tampered with or not, is essential to confirm, to notice a compromise, for example, and then to verify that the PLC is safe to operate after a potential compromise, and then ensuring that the PLC is still running the code approved by the integrator or the manufacturer, or the one that you signed off after an FAT. So you want to be doubly sure that that's the same code, right? But historically, most PLC engineers, such as myself back in the day, we would go to the project folder, look at the timestamp and say, yep, that's the last time I edited it. And most people don't enter enough information in that change management software, so you wouldn't even know what changed if something changed. So what we're recommending here is, If the PLC doesn't have any features to generate a hash or a checksum, you can still use the engineering workstation, the EWS, to generate the hash or checksum, and then you can upload the binary back from the PLC to compare. That way, at least you have a clear understanding of what code is in the PLC. Then you can say, okay, this is the same code that we expect to be there. But of course, some modern PLCs have the built-in checksum feature. If there is one, in these examples, Rockwell or Siemens, use it and then write that to a register so that you can historize it and alarm when changed. So that, let's say there's a testing or some kind of commissioning going on, there's an open permit. So the engineer is playing with the logic and downloading the controller. By all means, the operator can ignore it. But in the middle of the night, nobody should be touching the PLC, but you have this alarm that, the checksum on a PLC change. By all means, you have to pay attention to it because somebody could be manipulating that PLC code.
Interesting. Yeah. One of the things that, it's one of the things I've experienced with the software for programming is that you develop the program, but then the software itself uploads that, so it compiles and uploads it to the PLC. Is it commonplace that you can still access and get a checksum of that compiled code, or is that something that it is really vendor to vendor dependent?
Yeah, I think most PLCs you can have that compiled code binary. I mean, it's available on the engineering workstation, right? And then you can compare that back with what you downloaded or uploaded from the PLC. Because even that upload and download is different from PLC to PLC. But in my mind, I call anything from the PLC is upload to the engineering workstation. But yeah, so the PLCs that I'm used to working with, you typically get this binary. It's on the engineering workstation as well as you're downloading the same thing to the controller.
All right, and that's just a matter of know your tools, right?
Right.
All right. Thank you. Sorry.
Sure. Next up, another one, leave operation logic in the PLC wherever feasible. This is kind of interesting because over time, the user interface software, the operator visualization software has become more powerful. So you can add logic in the HMI itself without touching the controller. But what we're saying in this practice is try to keep all the logic in the PLC itself and not use the HMI for it because of these few reasons. So one, calculating the values closer to the field is going to be a lot more accurate. And that means the PLC because that's connected to the IO. And then there are, these infrequent updates to the HMI because there is latency between the HMI and the PLC. Obviously, the PLC is, runtime, whereas HMI has, maybe 1 per second polling as needed. So there is that latency. And then rebooting the HMI shouldn't cause any loss of status or values, which happens because if you have code in the HMI, but then you restart the HMI because there's a Windows update or some kind of patching that you did, that shouldn't cause any effect, but that's what happens if you put code in the HMI. And then force signals. So the PLC could have some force signals that make it not possible for the HMI to act, but it wouldn't know if the code is in the HMI. It might say, oh, I'm good to start, and then you start, but it hasn't actually started because the PLC has some logic forced against the start. Similarly, enable, disable actions, anything that's safety related, it's better off to be in the PLC itself, especially, if you have a time delay for a motor restart or something like that. If you have that in the HMI, but the HMI is not updating frequently or some issues, you don't want an impact on the motor. So we're recommending in this particular practice to keep all the critical logic, all the operation logic in the PLC itself. Some of the additional benefits besides security is, consistency in code maintenance. You have it all in one place. We talked about the checksum. It's a lot easier to just, do the checksum on one thing versus two different things. And then audit and change management is going to be a lot more straightforward if you have all the code in one location. And then it also reduces the attack surface. This is a second order security benefit. It's not as easy for someone that has, remote login credentials to play with what's on the HMI because the code is in the PLC. So to actually affect change, to do something, it's not as easy for them to manipulate an HMI that they have access to if all the code is in the PLC, because you then have to affect something in the PLC. So you have to go down the level to Purdue level 1 to make those changes. So that helps reducing the attack surface if you follow this practice.
Is there an industry that uses the checks within the HMI rather than the PLC more than others?
Yeah, I think, yeah, a few. For example, water, wastewater, SCADA systems. When you have some kind of powerful tool available on the user interface, it becomes a lot easier for people to kind of add stuff to it, right?
Okay.
Even in DCS, traditional DCSs, the reason why that software ended up being or becoming more powerful is it's just easy for an operator, for example, to add an alarm for himself or herself without having to ask the engineer to do it for them in the PLC, right? Hey, I want to have this additional alert, I'm monitoring this pump and I want to know this discharge pressure, be on a certain level, even if it's not a high alarm. An operator can do it on the HMI itself if they have access to it, obviously, and there is a functionality available. So over time, it kind of became possible for even integrators to add that logic there, because then they don't have to touch the PLC code, open that PLC programming environment. They can just do it from the HMI itself without going to their engineering workstation or fire up their laptop to do it on the PLC code.
Awesome, thank you.
Sure. Next up, another one. This is disable unneeded or unused communication ports and protocols. So historically, we've known that controllers, many of them are backward compatible. They're supporting many kinds of, protocols. But unfortunately, these protocols are enabled by default on a lot of these PLCs. So this practice says, disable them if you're not using them, right? Because every enabled port or protocol adds to the PLC's attack surface. And if it's not enabled, then the attackers can't use them. To use them, they have to enable them, which means you can then configure an alert or an alarm. And then that way you get a feel for what's going on in your environment. And of course, if you're using a network sensor or a firewall and you see traffic of a certain type, that shouldn't be, then that's another way to alert your SOC team or some kind of monitoring personnel. But of course, the best practice is to develop a data flow diagram so that it shows all the required communications, both the physical ports and the logical networks and protocols, so that you can get a feel for what should be in the environment, what's true and what's required versus what's not. The other advantages following this practice is it reduces the potential for malformed traffic to impact the PLC, cause it to crash, because that section, that protocol, that port is disabled. And then also reduces the overall complexity, because what's not there, what's not being used, doesn't need to be administered or updated. We hear a lot about software bill of materials. So in the future, you'll get a list from a vendor or the integrator about what all things are part of that software that you have. But if you have disabled a certain protocol and you're not using a certain section, then perhaps you don't have to update even if it's vulnerable, because it's not relevant to your particular application. So it's essentially a more kind of clean way of configuring your PLC to use whatever is needed, but then disable everything else around it that's not needed.
Yeah, and from my experience going in and looking at the attack surface within a lot of these environments, the process engineers, the programmers, and the operators, sometimes they don't even realize that they can go in and modify the configuration of these things, turning off web interfaces, web management interfaces if they're not needed, or enabling the TLS version of it, the secure communications version of it, and disabling the plain text or clear text version of it. That's just a configuration setting, but they never, because they don't look at it, because they haven't been asked to do it as a requirement, they don't check into it. So a lot of times, a lot of these services, that's one of my biggest jobs, is going in and just saying, hey, pull up the management interface of this. Hey, let's, if we can, and certainly you have to test, let's disable this FTP. I know you don't use it. Let's ensure that TLS is enabled on your web management interface, and let's drive on from there. You're going to be a lot better off. That attack surface is reduced.
Right. And this neatly ties into, some of the scripts that you were showing previously on other episodes down, where, it's similar to that concept where whatever you're doing on the engineering workstation or the HMI, do that at the PLC level as well, so you can disable the ports and protocols that, are not essential for the operation at that site. Next up is practice 11. This is a little bit more esoteric, because we're talking about instrumenting for plausibility checks. This requires the controls engineer to kind of work with the process engineer a little bit more hand in hand. So a couple examples. So one, comparing integrated and time independent measurements. So if you have a tank and there's a flow meter, for the tank level increase, and you got the level meter on the tank as well. So the volumetric change from the flow meter should be proportional to the volumetric change in the tank should be proportional to the flow meter, right? So that way, those two things are related. So if you see the tank level increasing, but there is no flow increase, or vice versa, that something is wrong. Similarly, if you have a boiler and the added caloric heat in the boiler should be proportional to the temperature increase. If they're not, if someone is trying to manipulate those values, you can create an alert to say these two things are proportional or should be proportional, and they're not. It could point out to a simple equipment failure. It could be a flow meter problem or the level indicator problem, or it could be that someone is manipulating those values. But this kind of practice will help you create an alert for it, so you can go take a look at it and see that these two things that are supposedly connected are somehow diverged at this moment.
Yeah, and this one seems like it's really using the power of the PLC itself with all of its inputs, just to kind of do some integrity checking on the inputs that it's having, and from an attacker's perspective, modifying both of those inputs at the same time, it can be difficult. I would even say it's extremely difficult. So I like this one a lot. I understand that this goes into some logic issues, having people that are trained up to understand the relationships between these things, but certainly that's why they're chemical engineers and electrical engineers and so forth. But I really like this because it makes that attack so much more difficult at this level. But also, I think that if it is implemented, security professionals need to realize when we're coming in and we're modifying values, that just because we can make a change and spoof an input or something like that doesn't necessarily mean that the process is completely broken, especially if they've used these strong programming practices. The device will check and protect itself. And we need to understand that when we're talking about risk around being able to manipulate some of those values.
Yeah, that's a great point, Don, because, I hear a lot of people talking about, how they can easily manipulate values on a Modbus register. Oh yeah, I'm going to be able to force this, tank level to, 50%, but the tank is, overflowing. Well, one of the practices, if done right, can then compare that tank level to something else, right? The actual flow meter going into the tank and say, hey, the tank should be overflowing now, but it's not. Now, of course, this assumes that the attacker hasn't looked at the correlation and manipulated both the values, but it just adds another level of complexity to their attack, like you mentioned. And then, in some cases, you can compare different measurement sources, like the tank level on the flow meter. Like this other example is compressor stall is usually indicated by a reversal of flow, but you also have increased vibration. So you can correlate that a little bit more nuanced there. But then other times, maybe you don't have two different sensors or two different types of sensors, but maybe you can look at the same sensor value via alternate communication channels. So maybe there's a backplane communication and a 4 to 20 milliamps, or some kind of alternate path so that you can measure the same thing, using two different ways. That way, if the attacker manipulated one value in one location, but not the other, you get an alert that someone is trying to play with these values. And again, like I mentioned, this assumes that not all sensors and values are manipulated simultaneously. But if you follow this practice, at the very least, it identifies wrong measurements. These two things should be correlated. Something is wrong, maybe the device is out of calibration, or something is wrong with the device. That's one thing easily identified with this practice. And then it also rules out the physical causes of failures more quickly, because if you know that the flow meter is wrong, then you wouldn't suspect the valve, for example, right? Then you don't have to go inspect the valve in the field thinking maybe the valve is out of calibration. Next up is this validate and alert for paired inputs and outputs. This too, again, similar to the previous one, you don't need artificial intelligence. You don't need a lot of extra, non-native functionality, because the PLC can look at all the IO values. And this is one of those things that the PLC can natively do. The paired inputs and outputs are those that are physically unable to happen at the same time. As an example, a motor can be either started or stopped, and the belt conveyor, could be going forward or reverse, or a valve could be, open or close, or going to open or close, but it cannot be open or close at the same time, right? Because that's how we define the paired inputs or paired outputs, meaning these two cannot physically happen at the same time. If, for example, a valve gives you feedback, both limit switches are on, meaning it's open and closed, well, then you know for a fact that something is wrong. It could be that the limit switches failed, or someone is manipulating values and they just, try to enter, a Modbus register full of ones, so all of them are now one, for example. In this practice, we also added a couple other, ancillary support recommendations. So one is to configure distinct outputs, if possible, instead of just one, to an MCC, the motor control center, for a start-stop. If you have a start for the motor and a separate stop for the motor, it's much more difficult for the attacker to manipulate both of them to rapidly toggle on and off, versus just one register, one output going to the MCC. Then it's easy to toggle on and off, right? So if you have two separate ones, it's much more difficult, but that needs the MCC to support those two outputs, and you have, physical cable or some kind of communication for, two outputs to the MCC.
So are these paired inputs and outputs common, so already in place, or is this extra consideration that they would need to build into the process, put extra lines out there, a direct or smart IO to the process?
That's a great question. I mean, most of these historically have been done for reliability or maintenance purposes. I mean, like a valve, for example, the limit switches on the valve, if both of them show on, right? Most PLC programs will alert you for that, because the process engineer or the controls engineer, has configured that as an alarm to say something wrong, right? Not necessarily with security in mind, but they did that for maintenance purposes, because then you can go take a look at that limit switch to see which one is faulty. You command the valve to go open, but the closed limit switch doesn't change, but the open limit switch comes on, then you know for a fact that the closed limit switch is faulty, right? So historically, there were some that were configured for that kind of a benefit, but because now we're saying there is a security benefit to it, if you did not include that on all the process, controls like this, you could probably add it. And this doesn't need any additional field hardware or IO. Is just taking advantage of what you have already and comparing them to say, hey, I shouldn't get these two at the same time. I'm getting one, which is good. I'm getting the other, which is good, but I shouldn't get both at the same time. So this just needs an additional one piece of logic that you can replicate across the board, but not need any additional hardware. And then you can also add a timer outside of the PLC if possible, but also a soft timer for a restart, so that, again, we're trying to add to this practice by saying, and if you have a restart, try to avoid a rapid, toggle on the restart by adding one more layer in between, so that an attacker cannot easily just force one bit to 0 and 1 and constantly toggle, like the Aurora attack, right, where they force the breaker to open close rapidly. Maybe this is not a breaker, maybe this is something else, but you're trying to avoid something to be made on and off rapidly. We talked about a few of the validation practices for integrity checks. Now let's talk about monitoring. This practice number 16 talks about summarizing PLC cycle times and trending them on the HMI. So the cycle time is the time it takes to compute each iteration of the logic in the PLC. And most PLCs give you this option to either display it, or maybe it writes to a register that you can copy. And also most PLCs have this Tmax, this cycle time, will shut down the PLC because it's overloaded. The CPU usage is too high. However, most code is typically, 20, 30%, 40% utilizing the CPU time, and the cycle time for the PLC is within a tolerable range. In a deterministic PLC, this is predictable. It shouldn't change. However, if an attacker has added some code to the PLC and you were not able to recognize or identify that change elsewhere, this is maybe one of the way to monitor, right? Where you didn't do anything else or you couldn't do any other practices, but you're just monitoring the CPU cycle time. Any additional code will have an impact. It will increase the CPU time. And if you log it and monitor as a trend on the HMI, in this example, like every so often you have this spike, which kind of shows that something is being executed at the time. That's another way to kind of identify additional code or additional code execution on the PLC. Now, attackers are also clever. They try to keep the additional code as lean as possible, but having this trend kind of gives you this visualization over time that something is executing every so often a little bit different from what the process is expected to do at the time. So just get a good feel for the operator or the controls engineer that something is wrong, and then they can go inspect this anomaly.
So isn't this something that's already in the data historian, the communications, the everything that's going on in the PLC should be passing back. At least that's kind of, if you haven't programmed PLCs and don't know about these environments, you would expect everything's going back there. So is this typically something that you would see or would not see in the data historian's information, and it specifically needs to be added?
Yeah, this is not usually seen in the data historian. So number one, this might not even get out of the PLC. So this might never be on the HMI. These cycle times, or there are other monitoring practices where we recommend monitoring the memory usage. Those things are usually available in the PLC, but they're diagnostics only. So you probably have to connect the EWS or a laptop to be able to look at these things. But most PLCs will allow you to write these to a register. And then, of course, you can trend them, historize them, connect them to your historian, send data over to the HMI for the trends. But you have to do it manually, or you have to do it on purpose, because historically this was not done. So most of these were diagnostic tools capable of doing this work, but were never really done because, who needs that? Like, why would you worry about a CPU usage if, everything is fine and the PLC is running? There was never any concern about, attackers manipulating the CPU or the PLC code and that causing these spikes to happen. But that wasn't something the operator or the controls engineer was required to track. So
Absolutely.
This is something that you additionally configure.
Yeah, and from an incident responder standpoint, information is information. It feeds, a lot of times we can understand things better when we can correlate disparate information that supports each other. So this type of thing really kind of helps either build upon the story, or at least point us in a direction of, hey, we should be looking over here at this type of thing. So I really, as much information as I can get that is, still cost effective, I definitely want. So hopefully this people start looking at some of this type of data too.
Yeah, this is great. I appreciate your IR perspective on it, because this definitely helps on top of all the Windows-based logs. If you have this kind of information available, it kind of gives you another data point for what could have happened in the PLC during the incident response. Absolutely. So for the most part, I think that's all I had in terms of practice descriptions, but I do want to talk a little bit about the project and what's going on right now. And like I mentioned, this was a community project that we worked on for about 1.5 years. Right now, we're doing a lot of translations into multiple languages. Currently, we have German, Turkish, I believe Portuguese and Spanish as well in progress. We have a few that are published already on the website, Chinese as well. But more translations are coming. So the intent is to provide as many translations as required to more engineers around the world who are programming the PLCs. But we're also taking feedback from the community. If you go to that plc-security.com, there's a feedback form where you can let us know if you've been doing something different that we haven't incorporated. Please tell us, and we'll try to add that in the next version. Or if you see something that should be worded differently or added, please give us that feedback. Like I mentioned, MITRE CWE, we have a collaboration with them. If you want to be part of that, please let us know. We'll include you in the team. We'll request MITRE to add you to their recurring calls. If you are any of these, if you belong to an engineering association, or if you're a PLC vendor that want to incorporate these practices, please let us know. We'll share the actual Word document with you, and you can view, modify, edit as you see fit for your purposes, because the license for this PDF is very much in that collaborative mindset. There is no charge. You can use it for both free and commercial purposes. And of course, I'm doing this kind of presentation thanks to Don's support. So if you're willing to have us on for a training session or an article or a podcast, please let us know so that we can give this to more engineers, because the intent is to not give this to an OT professional who looks at all this and say, yeah, this all makes sense, and aren't you not doing this already? That'll be the question from an OT professional. But if you ask an ICS engineer, maybe not so, because they might have been doing a lot of these or maybe all of this for other reasons, but they were never really considering this for security. So we want to put these practices list in more engineers, more programming folks' hands. So please help us do that.
Yeah, that was one of the, because, my talk at Houston SecCon, one of the comments I got from the audience is, aren't people doing this already? And, it's that could have been asked. I don't think it was asked at your talk, but it very well could have been asked. But certainly we both, you and I know, we wouldn't be doing this if it was, and putting it out there. And the fact that the team is willing to accept requests for training and so forth, and take that into consideration. I think that's a huge part of this project, and I'm glad you all are doing it. So thanks for keeping this going forward, and for trying to reach out to the industry.
I appreciate it, Don. I mean, I really appreciate you having me on, because we're just trying to get the message out there about, a document that engineers can have and follow, because that wasn't available. So historically, you have HMI design practices about what colors mean what. You had alarm practices about what should be an alarm versus what should be an alert versus what should be a diagnostic. We had all these different things that engineers were very well aware of, but there was never a list that we knew of where you could tell an engineer, hey, think about these things when you're programming PLC. So a lot of this is common sense, but that common sense is not as common as you would imagine.
Right. Yeah. It's better to have a list, at least, double check yourself. And, there's a lot of smart people. The programming of PLCs, the development, the management of processes, that, there are smart people that are doing this, but even they need assistance associated with, okay, here's my checklist. Have I taken these things into consideration? Right. That's a great start. Even if they go down and say, okay, that doesn't apply. That's an easy, 5-10 minutes. Maybe you pick 2 or 3 that, take you an hour to work out with your team. Hopefully it's that easy. But certainly this is something that they can leverage. That's awesome. Hey, Vivek, I really appreciate you coming on and talking about this. If people have questions for you, what's the best way to reach out to you? Is it LinkedIn? Is it Twitter? Is it through the project page? Where would you like to send people?
Yeah, I think the easiest way is to, give us a shout on Twitter. Secure PLC is our handle there. Okay. Or go to this website, plc-security.com, where we publish the email and the Twitter handle as well. Either way is good, because we're monitoring. We have a couple of volunteers that monitor both the Twitter handle at Secure PLC and the email address that's published on the website.
Excellent. That's awesome. And I'll make sure that all of that's in the show notes so everybody will be able to find it. Any last minute thoughts before we let everybody go?
Just a quick thing, like I mentioned, we focused on the PLC coding practices itself. If you are interested in kind of expanding the practice list, if you see something that we should be adding, please, let us know and be part of the project. That plc-security.com will also give you a way to send us an email to let us know that you want to be participating in the monthly calls or be part of the project. So we invite anyone from the vendor community to the integrators to the asset owners. So the more participation we have, the more we can refine these practices for a more purposeful application and security. So I appreciate anyone considering joining, because we could definitely use more people in helping us achieve this goal of securely programming PLCs.
Awesome. Yeah, we're all in this together, and I perfectly agree with you. Well, I appreciate your time, sir. Thank you for joining us, and you have a great week.
Thank you, Don. Thank you for having me.
Yes, sir. Have a good day. Thank you for tuning in to another concept overview with the SANS ICS and Cutaway security teams. Please let us know if there are other topics you would like us to cover in the comments below. If you enjoyed the content, please be sure to like and subscribe to the SANS ICS YouTube channel. This has been Don C. Weber of Cutaway Security. Go forth and do good things.